Alright, so today's the first day of Unit 5, Solve Systems by Graphing. So the only new part here is that we have systems, but graphing is the same that we did before. So our only vocab word is systems of equations, which is a collection of two or more equations with two or more variables. And then the one important thing is the number of equations has to equal the number of variables. We'll only be dealing with 2 variables, 2 equations, but you can have 3 variables, 3 equations, and so on. Alright, so the first thing we're going to talk about is the different numbers of solutions that you can have. You can have exactly one solution where the 2 lines cross. So that point right in the center where they cross would be your solution, because we're trying to figure out when would they have the same x value and the same y value. So that would be the point that they cross. That would be the spot where they both have that x and y value that satisfy the equation. The other option is we would have infinite solutions, infinitely many solutions. That is where we have the same line. Okay, so for an example of your system, you could have x plus 4y equals 12 and y equals 3x minus 6, something like that, where you have 2 equations and you have an x and a y. So in order to have the same line, that would be like when you solve these both for y and you have the same equation, it would be the same line. The other option is when you have no solution, and that would be when your lines are parallel, which we talked about that, finding lines that are parallel before, so we would be comparing their slopes. Alright, so example 1, we're just determining the number of solutions. For part A, my 2 lines cross right there, so that would be 1 solution. And in order to find that, I could look at my x value. So here's the origin. So it would be 1, 2 for the x value, 1, 2, 3, 4 for the y value. So the point would actually be 2, 4, and that would be the solution. Part B, the 2 lines are parallel, so this would be no solution. And then part C, they are the same line, so this would be infinitely many solutions or all real numbers. Either of those is fine, just like we've used before. So some examples, we first are just going to start with graphing. So it says determine whether the system, don't worry about this wording up here. We're not going to use this exact wording, but you need to tell me how many solutions there are. Okay, so determine the number of solutions. Okay, so obviously with graphing we need to make sure we're solved for y first. Here I'm solved for y already, so I can just start graphing. So for the first equation, my y-intercept is 1, and then I have a -1 slope. So I'm going down 1 over 1, down 1 over 1, down 1 over 1. Okay? Then I can connect those. And there's my line. Okay? I'm going to zoom in a little bit here. For the second one, I start up at 4, and I again have that same -1 slope. So down 1 over 1, down 1 over 1, down 1 over 1. And there would be my line there. Okay? So we can see from our picture that it doesn't look like they cross. Just because it doesn't look like they cross on my graph doesn't mean that they're parallel. We need to look at the slope. But I have a negative 1x, those slopes are the same. So they would be parallel, which means there is no solution. Now for b, the first equation's already solved for y, so I'm going to graph that one. So we go up to 3 on the y-axis, and then a slope of 2. There's my line. This second equation needs to be solved for y, so I'm going to subtract 8x from both sides. Negative 4y equals negative 8x minus 12. Divide by negative 4. So I get y equals 2x plus 3, okay? 2x plus 3, 2x plus 3. Those are the same line. If you want to go ahead and plot those points, you can. But they do end up being the same. So that would be infinitely many solutions, all real numbers. Either of those two is fine. Okay. Example 4, it says Mariah and Diego love to ride bikes. The equations below show the number of miles they ride m. Okay, number of miles they ride m. Based on the number of weeks, predict the week in which Mariah and Diego will have ridden the same number of miles. Okay, so the number of weeks is my independent variable because the number of miles that they ride depends on how many weeks they've been riding their bike for, right? So they're both already solved for what would be considered my y value in this case. Okay, so we can start labeling our axes. The x-axis would be our number of weeks. I'm just going to label 1, 2, 3, 4, 5, 6, 7, 8. And then our y-axis would be number of miles. Number of miles ridden. Oh my goodness. There we go. That was tough. Okay. And then I'll just go by fives. 5, 10, 15, 20, 25, 30, 35, 40, and we'll stop there. That should be good. Okay. Oh, no, it's not. Gotta go 45, 50, 55, 60. Okay. Now looking at my equations, you guys don't need to make these scales, but this would be my y-intercept because there's no x value. This is my slope, so that means each week, I don't know who's who, but someone's riding 35 miles a week and someone's riding 25, so this scale needs to be a little bit bigger. So let's go by tens. 10, 20, 30, 40, 50, 60, 70, 80, 90, 100, 110. That should be good. Okay. So first line, we start at 20, and then I'm going up 35 for each week. So from 20 to go up 35, that would be at 55. So I'm going to be in between 50 and 60. Then going up 35 from there, that would be at 100. Okay. Yeah, 55. No, it'd be a 90. Okay. Then from there, 90 plus 35 would be 105. No, oh my goodness, 125. Okay, that's going to be a little bit off of our graph. That'd be like up there, but that's okay. Now you can connect those. There's my first line. Second line, I always put the little dot next to it so I know which line represents which equation. If you want to use different colors, you can too. So I'm starting at 50 for this one, and now I'm going up 25 for each week. So that would take me to 75. and then that would take me to 100. And then after that, that would take me to 125, which would be that point that's just off our graph. Okay? So, when would they be riding the same? That would be this point, which is 125 miles at 3 weeks. So we can write that as a point, 3, 125, or we can write it in words. So after 3 weeks, they both rode 125 miles. So either of those would be fine. Go ahead and try the You Try Now problems, and then you can continue playing and check your answers. So these both first need to be solved for y. Y equals 1/2 x plus 1. So if you notice right away that their slopes are the same, that would be fine. But you can also just graph so you can get that full picture. Okay, so those, even though my lines are a little slanted here, always make sure you double check their slopes if you think they're going to be parallel, because that's what tells us that they're parallel, okay? So this one would be no solution. And then our last one, we'll do a little line break here so we can start at a different value. Let's start at 50. Okay, so this little line that I drew in there just means that I'm not starting at 1, like I'm not following that same scale. I guess you could have started at 25 if you want, but it doesn't really matter. Remember, I'll give you the numbers so you don't have to worry about how to make that. And then they're saving money after a certain number of weeks. So this is going to be money saved. And this is number of weeks. 1, 2, 3, 4, 5, 6. Okay, so first equation, I'm starting up at 100 and going up $25 a week. Okay, so there would be my first line. Second line, I start at 75 and go up $30 a week. So 75, that would bring me to 105. Okay, since it's not on an exact line, you really need to remember what your points are, so you can just add. So from 75, if I went up $30, that would put me at 105. Then the next week would be 105 plus 30 would be 135. Then plus 30, 165. Plus 30 would be 195. And then I would be at 225. Okay. Again, super important to have your points very clearly visible. See how even though my line wasn't exactly on those points, because I could see where those red dots are, I knew that even though it looked like they had crossed, they hadn't actually crossed yet because the dots were not in the same spot. Okay, so this would be my answer. There would be one solution, and it would be after 5 weeks, they both saved, I don't need to write that there, they both saved $225. And then we want to write that as a sentence too. After 5 weeks, they both saved $225. Okay, we will be going over this on Monday, so don't stress too much if you're not understanding some things. And then your homework is attached, so you guys can go ahead and work on that. Thanks.